Today we're going to look at another way to find the vertex of a quadratic. So as a review, try A, B, and C. Locate the vertex of each of the following quadratic functions. Well, if you remember, the vertex is where it changes direction. So if it's a downwards facing u, the vertex would be the maximum. If it's an upward facing u, the vertex would be the minimum. We've also talked about the discriminant and how that, the discriminant of quadratic and how that, there are, if you look at the discriminant and if they're under the radical sign is positive, here again there's two zeros, so that discriminant would be positive as well. And here you would have a negative under the square root, and there would be an imaginary root because it doesn't touch. Here are methods that we know so far. We could graph it. You have the graphing calculators. You could type in the function and look for the vertex that way. You could change the equation to vertex form by completing the square, and you could see how it shifts up, down, left, or right. And then today we're going to look at the new method. And we're going to start by looking at the quadratic function f of x equals x squared minus 4x minus 5, and by using quadratic formula. So as a review, this is already in standard form. What that means is x to the highest power is first, minus the second highest power of x, and then we have minus the 5. Let's find a, b, and c here. So a would be the number next to the x squared, which is 1 in this case. B is the number next to the x, which is negative 4 in this case. And c is the number by itself, which is negative 5 in this case. Using the quadratic equation formula, we can get the x-intercepts by plugging in. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so here the work is shown for you. Note that gives us 4 plus or minus the square root of 36 over 2. Remember again, if I ask you to use quadratic formula, I would want to see this work, these two steps shown. We would have 4 plus or minus 6 over 2, and that gives us 4 over 2 plus 6 over 2 if we divide this up, or 2 plus or minus 3. Now, the question is, how can you use the 2 and the plus or minus 3 to get the zeros? Now, if I'm graphing this function, I can give you a visual representation. I try to pull up my graphing calculator, but it's being slow. So I will just sketch this function for you if we were to type it in the graphing calculator. So here's my y-axis, my x-axis. And what this means is, let's draw the function. Okay, so if we graphed it, we would have a quadratic that looks something like this. And you would notice something, if I would have pulled up my graphing calculator. Okay, you would have noticed something about the vertex right here and the zeros of the function. The question is, how do you use the 2 and the plus or minus 3 to get the zeros? If we would have pulled this up on the graphing calculator, we would have noticed that this blue line right here is x equals 2. So this is 2 right here. And to get the zeros, we would either add 3 to get this point, or subtract 3 to get this point. So again, if we have this middle number here, the 2, if we add 3, we would get the first 0, and if we subtract 3, we would get the second 0. Okay, so again, if we use quadratic formula, not only can we find the zeros, we can actually find the vertex as well. And we have not practiced doing that. We've just found the zeros, the roots, the x-intercepts using quadratic formula. How can we easily get the 2 in the first place? Well, remember how we got the 2 before. Using quadratic formula, it was this part, 2, and that came from this 4 divided by 2, and if we go up, again, that comes from this right here, and if you remember, this is b plus or minus something, and we're not looking at that right now, all over 2a. So to find that 2 value, it is b over 2a, and again, that will give us this 2 that we want before we add or subtract the 3 to find the zeros. And again, we're looking here for the vertex, this 2. The x value is 2. And again, to do that, we can look at b over 2a. So let's write that in. How can we easily get the 2 in the first place? Again, that was the b over the 2a. And once we did that, remember for this value it was, actually it was opposite b over 2a, I should say. And so that was negative 4 over 2 times 1, which gave us the 2. That was this x equals 2 right here. But the question is, how can we get the y value of negative 9? So we don't know what this is. How could we get it in ways other than graphing? Well, if you know the function, f of x equals x squared. Oops. I can't remember the function, so let's look back. X squared minus 4x minus 5. So here's our function. We know the x value now. X is 2. So let's plug that in. We'll find f of 2 equals 2 squared minus 4 times 2 minus 5. And if you solve that, f of 2 would be negative 9. And that's our vertex, 2, negative 9. Okay, so again, to remind you, we're looking for another way to find the vertex besides graphing and putting it into vertex form by completing the square. We can use quadratic formula. Here are the steps. Number 1, put the quadratic in standard form and identify a, b, and c. We did that. Find the x-coordinate of the vertex by plugging in for negative b over 2a, or opposite b over 2a. When you find x, plug into the original function and solve for y. So let's do a few examples. Let's find the vertex of each of these using quadratic formula. First step is put it into standard form. It is. So here's the first step. Second step is do the opposite of b over 2a, and that will give us x. So if we plug in, b here is negative 4 again. So opposite of negative 4 over 2 times 1. So again, in this case, we get x equals 2. So that gives us the x-coordinate. We need the y-coordinate. So step 3 is plug in f of 2 into our function. So 2 squared minus 4 times 2 plus 7. And if we solve that, 2 squared is 4, minus 8 plus 7 would give us 3. So the vertex of this function would be 2, 3. And if I asked you, is that the highest point or lowest point of this graph? Well, we know that's a u facing up. It would be the lowest point at 2, 1, 2, 3. Our function, if I asked you to sketch, would look something like this. All right, let's try another one. Find the vertex of this parabola. First step, put in a standard form, and it is. Second step, plug into opposite b over 2a to get x. So that would be opposite of negative 12 over 2 times a, which is negative 2. We get 12 over negative 4, which would give us negative 3. So here x equals negative 3. All right, we need the y-coordinate, so there's the last step, 3. Plug into the original function with x equal to negative 3. So we get negative 2 times negative 3 squared minus 12 times negative 3 minus 23. So we're just plugging in, and if you solve this, you get negative 5. So the y value equals negative 5. So the vertex of this graph is at negative 3, negative 5. Here's our vertex. If I asked you to sketch the function, notice there's a negative 2 here, which means it's an upside down u. So this would be the highest point at negative 3, negative 5. It would look something like this. Let's try one more, and then you'll have several of these to practice for your assignment just to find the vertex using quadratic formula, part of quadratic formula. First step, put in a standard form it is. Second step, plug into negative b over 2a, or opposite b over 2a. So here b is 24, so we would have negative 24 over 2 times negative 3. There's the a value. We would get negative 24 over negative 6, and that would give us 4. So there's the x value of the vertex. We need the y value. Let's plug in f of 4 equals negative 3 times 4 squared plus 24 times 4 plus 48. So the y value, when x is 4, would be 96. So the vertex of this would be at 4, 96, and this would be our maximum because this is in downwards facing u. So this one I won't sketch, but it would be over 4 up 96, downwards facing u. There would be the vertex. So your assignment then is to practice finding the vertex of each of the parabolas below, and then you have a word problem application.